Hi everyone, welcome to this video on the topic insertion sort. In this video, we are going to see about the fundamental sorting algorithm that organizes data efficiently. Let's see what is insertion sort. Insertion sort is a sorting algorithm that works similarly to how you might sort playing cards in your hand. It builds the final sorted list one element at a time by inserting each unsorted element into its correct position within the sorted sublist. So, insertion sort sorts a list of elements in ascending or descending order. Let's see one example. Imagine you have a deck of playing cards in your hand. Insertion sort is like building sorted sequence card by card. You start with the empty sorted pile and pick cards from the unsorted pile, inserting them at the correct positions in the growing sorted pile. Let's see how insertion sort works. We begin with an empty sublist representing the sorted elements and then iterate through the unsorted elements one by one. For each element, compare it with the elements in the sorted sublist. Then find the correct position for the current element based on its value and insert it at that position. Then continue iterating and inserting elements until the entire list is processed. Here is one simple example in ascending order. Let's consider a list that includes 8, 3, 1, 4 and 2. In the first pass, we take 3 and compare it with the empty sorted sublist. Since it is the first element, so we insert it directly, 3. In the second pass, we take 1 and compare it with the element in the sorted sublist, that is 3. Since 1 is smaller, we shift 3 one position to the right and insert 1 at the beginning, that is 1, 3. Then continue with this process, comparing each element with the sorted sublist and inserting it at the correct position. So, building the final sorted list that includes 1, 2, 3, 4 and 8. Here we have one simple example program using insertion sort. Here the insertion sort function takes a list of data as input. Then it creates a copy of the data list to avoid modifying the original during sorting. It iterates through the list starting from the second element, that is index 1. The first element is considered a sorted sublist of size 1 by itself. In each iteration, the current element to be inserted is identified and then use a variable j to iterate backwards through the sorted sublist, that is the elements before the current position. Then compare the current element with the elements in the sorted sublist. If the current element is smaller than the element in the sorted sublist, we shift the larger element one position to the right, creating a space for the current element. Once the current position is found, the current element is inserted at that position, that is j plus 1. The function returns the new sorted list. So this example demonstrates how insertion sort builds the sorted list element by element, comparing and shifting elements as needed. Then applications. Insertion sort is particularly useful for small data sets or situations where the data is partially sorted. Being in place, it's memory efficient. Then comparisons with the selection sort. Both insertion sort and selection sort have similar time complexity in the worst case. However, insertion sort might perform fewer swaps in practice, especially when the data is partially sorted. The choice between these algorithms often depends on specific use cases and coding preferences. So this is about insertion sort. Thank you.